This video looks at question A on J5 of the Junior Challenge 2020 snake-like numbers. Okay, so question A says how many 4-digit snake-like numbers contain each of the digits 1, 2, 3, 4 exactly once? So we're asked to find a permutation. A permutation is a combination where or an arrangement where position matters. So for instance, in a permutation A, B, C, D, one permutation could be A, C, B, D. So the position of each of the letters matter. Okay, so let's just do this problem, and instead of doing a 4-digit, I will do a 3-digit, and then we'll look at a 4-digit. Let's do 3. Question A, how many 3-digit snake-like numbers contain each of the digits 1, 2, and 3 exactly once? Okay, so we have got each of our snake-like numbers is going to look like this, and we are choosing from 1, 2, and 3. Okay, so the first thing we need to find out is how many permutations. Okay, this is important because we need to consider every permutation and ask, is it a snake-like number? Well, we can choose the three ways. 1, 2, 3. 3 ways of placing the 3. So let's put the 3 there. For example, now we have 2 ways of choosing the 2. So how many permutations? We're going to say, let's do P. So we have 3 ways of choosing number 3. We have 2 ways of choosing to put the 2. And we have 1 way of choosing the 1. So that gives 6 permutations. And that is the same as doing 3 factorial. So 3 factorial means 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So factorial is an easy way to find the number of permutations. Okay, so let's list those. Let's list the permutations. Okay, so when we list in permutations, we've got 3 numbers. So we can do a little calculation. So 2 of the numbers are going to begin with 1. 2 of the numbers are going to begin with 2. And 2 of the numbers are going to begin with 3. Okay, so let's do that then. So we've got 1, 1, 2, 2, 3, and 3. Okay, well, let's go 2, 3, 3, 2. Now we've got 1 and 2 to choose from. 1 and 2. 1 and 3 to choose from. Now we can do 3, 1. We've got 1 and 2 to choose from. Then we've got 2, 1. Okay, it's useful to find a method of writing these permutations down. So what I did here, once I wrote the first number down, we only have 2 numbers left, so 2, 3, and I switched those 2 numbers here. We started with 2, so the 2 numbers left are 1 and 3. I switched to get those. Start with 3. The only 2 other numbers are 1 and 2, and I switched them here. Okay, now we need to choose which of these is snake-like, and we do this by inspection. That goes up, and that goes up. That's not snake-like. That goes down. Doesn't. That goes up. And that goes down. So this is a snake-like number. This goes down, and that goes up. That is snake-like. That goes up, and that goes down. This is snake-like. This goes down. That goes up. So that is snake-like. That goes down, and that goes down. So the snake-like numbers are 1, 3, 2, 2, 1, 3, 2, 3, 1, and that's it. 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2. So let's look at the original question. How many 3-digit snake-like numbers contain each of the digits 1, 2, and 3? Well, the answer is 4. This is our answer. Okay, now let's go back to the original question. The original question was how many 4-digit numbers? Let's change this to 4. How many 4-digit numbers? Exactly once. Okay, so let's do this again. We've got 4 digits, and we choose from 1, 2, 3, and 4. Okay, again, I hope you can recognize that this is going to be 4 factorial, which is 4 times 3 times 2 times 1, which gives 24. We can explain this by showing, I'm going to do permutations, showing that there's 4 places to choose number 4. 1, 2, 3, 4. Pop the 4 there. Now there's 3 places of choosing 3. Let's pop the 3 there. The 2 ways of choosing the 2. And there's 1 way of choosing the 1. So we've got 24 permutations. Again, we've got 24 divided by 4, and that gives 6. So we can have 6 numbers starting with 1, 6 numbers starting with 2, 6 numbers starting with 3, and so on. Okay, so let's do this methodically. And let's adopt a strategy for writing the entire list out. So we got 24. And so we're going to have 4 groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And let's go here. 1, 2, 3, 4, 5, 6. So we have 4 going down. And we have 6 going across. 4 6s are 24, and our permutation number is 24. Okay, so let's begin. So we're going to have 6 numbers starting with 1. 1, 2, 3, 4, 5, 6. We're going to have 6 numbers starting with 2, 2, 2, 2, 2, 2, 2. 6 numbers starting with 3. And 6 numbers starting with 4. Okay, now, so I hope you can recognize then that we're going to have 2 ending with 4, 2 ending with 3, and 2 ending with 2. We're not going to have 2 ending with 1 because we're not allowed repetition, and we've already used 1 at the beginning. Okay, so how do we decide which numbers to put in here? Well, the only numbers remaining are 2 and 3, and we switch them here. 3 and 2. 1 and 3, the only numbers remaining are 2 and 4, and we switch them here. 1 and 2, the only numbers remaining are 3 and 4, and we switch them here. You can develop other ways of writing permutations, but this is the way I like. Now, you'll need to do this for the rest of the group, and then by inspection, you will need to decide which are snake-like numbers. So I'm just going to look at the first row and decide which of these are snake-like numbers. Okay, so we're going up, and we're going up, so that is not a snake-like number. We're going up, down, then up, so that is a snake-like number. We're going up, up, not a snake-like number. We're going up, down, up, snake-like number. We're going up, up, not a snake-like number. We're going up, down, down, not a snake-like number. So on the first row, we have 2 snake-like numbers. So on the first row, we have 2 snake-like numbers, and you will need to do that for the rest of the list, and that is called the sieve algorithm, where we look at each number, each permutation, and decide whether it's a snake-like number. Okay, now please have a go at doing J5 and upload your solution.